मच्छरदानी लागे रही का ये फ्रिज में जूस तो नहीं खा दो कुछ जीवू हम कहाँ हम जीवू जीवू अरे स्कूल नहीं करता आज छुट्टी है हैं आप पहले ये थे आप पहले ये थे आप पहले
So the problem today we are going to solve is question number 2000 3296 and हम इस प्रॉब्लम को सॉल्व करने जा रहे हैं. The question is minimum number of seconds to make mountain high at zero. Question name is minimum number of seconds. Uh, we will be given a problem and we are supposed to pitch the minimum number of seconds that will require to make the mountain of the height of zero, right? So there must be will when array there must be an array given for which we will be having some operations around. Let's try to understand what exactly the question is and how we can understand we can solve the given we can solve the problem and can have the solutions as well, like so. Let me try to print this page if possible. Um, okay, so there is no such a way that I can print with examples. So I'll try to print the page. I will try to take a snapshot of this. First, I'll try to understand what exactly the question is. Then we'll go a snapshot with a snapshot and making a clarified version of the question, right? The question says that you are given an integer which name is mountain height. So we are given an integer with the mountain height, right? Which denotes the height of the mountain we are supposed to maintain or create in the output session, right? And again, it says that you are also given an integer array. So we are also given an integer array which name is worker times, right? Representing the work of time, the work time of the workers in seconds. Okay. And next it says that the worker works simultaneously to reduce the height of the mountain for the worker I. So it is actually given what till now I was able to understand what exactly the question is, that the question says we are actually given the height of the mountain, and we have to find the number of the second that will be taken to reduce that mountain height to zero, right? To zero. And it says that representing times of workers in seconds. And again, it says next line is the worker works simultaneously to reduce height of the mountain. And for the worker I, there are certain number of operations that we can perform. And the very first operation that we are supposed to perform is to decrease the mountain's height by x. So if I am willing to decrease the mountain's height of by x, it takes worker times as it is array, so there will be numerous elements. Worker or I and worker I multiplied by 2 plus to the ith of x second. What is it? बैकग्राउंड में इतना शोर हो रहा है ना, मेरा सर भी फटा जा रहा है. How people can see, you can hear what exactly the sound of background is saying, and how terrible to stay here and focus on the studies. Okay, so it says that to decrease the mountain height by x. Oh God. To decrease the mountain's height by x. So if you are willing to decrease the mountain of, let's try to understand the question by example. It says that we are given mountain height with the with 4. Worker array is given as in 2 comma 1 comma 1, right? Our integer array is given in the question is 2 comma 1 comma 1. And okay, so if now our task is to reduce this mountain height from 4 to 0, right? And if we are how will pick, there is no such an integer given as an x. So if we are willing to decrease the mountain height by x, and x is actually the mountain height, which is 4, and definitely we are supposed to decrease the height as possible. because it is the 4 is the height of the mountain, and we are supposed to uh, we are given a task to turn this height into 0, which means we have to reduce this size, the whole we have to minus, we, we have to add with the minus negation of this same value, right? Okay, so if we let me try to understand what exactly the operations out there, because it's wrong and people so insensitive. So to decrease the mountain's height by x, it takes worker times I plus worker time I multiplied by 2 plus worker time I multiplied by x at 3 plus 2x, right? So it says that x cannot be the same value as in mountain height, because as we can see here, we have the array as in 2 comma 1 comma 1, and the max height where mountain height is given 4. Our operation is to decrease x, right? To decrease the mountain height by x. So if we are willing to decrease mountain height of 4, so it will be somewhere like, right, it will be somewhere like we can try it. The worker of I, first as I will be incremented, right? So first it will be I is equals to, let's say we have taken I is equals to 0. So it will be I, which is 0 multiplied by 1, right? Then worker of 0 multiplied by 1, 2, right? And worker 0 multiplied by 3, and we are supposed to do with multiply with the 4 till 4, so it will be worker of 0 multiplied by 4, right? Okay, so if we'll put the information data and the operation part, it will be somewhere like worker of I is 2, 0 is 2, 2 multiplied by 1 will be 1, plus 2 multiplied by 2 is equals to 4, plus 2 multiplied by 3 is 6, plus 2 multiplied by 4 is 8, which is somewhere like 4, 10 plus 10, 20, right? It will be 20, decrease 4. Yeah, so decrease the height of the 4, it will be like decrease 4. We will get the it says that x seconds, so it will take 20 seconds to decrease the very first time, to decrease the mountain 4 starting from, right? And if I'll take okay, to decrease the reduced size, first it will take this pattern, right? So it says that worker 0 to reduce the height by, and will take 2 seconds. Okay, so one way to see, I'm trying to understand. Okay, so it was the first operation that was given in the question, and the second operation is to reduce the height of the mountain by 2. It says that next is, it says that to reduce the height of mountain by 1. So it was the like, first was to reduce the mountain height by 1. It takes worker of I seconds. What? Worker of I seconds, right? Worker of I second, it simply means okay, worker of I, and here I is not given. So to reduce the mountain by side, and again it says that to reduce the height of the mountain by 2. it takes worker of I plus worker of I multiplied by 2 seconds and so on. Right? Okay, so if we'll try to reduce the worker of height by 1, so we each time we have to do the worker I is equals to somewhere like so start from the 0 and our array is for 2 comma 1 comma 1, right? So first we'll write the worker 0 will reduce worker 0 will reduce the height by 1, right? And it will be somewhere like worker of 0 multiplied by 1, it will be 2 seconds. It will take 2 seconds, right? And again, it says the worker 1 will reduce the height by 2, and it will be like 2, right? Worker 1 will, right? So it will be worker 1 multiplied by 1 plus worker 1 multiplied by 2. So it simply means 1 height by 2, it will reduce the height by 2, and it will be somewhere like work and one value is 1, so 1 plus 2 is 3, so height 2 will be reduced by 3 seconds, and worker 3, if he will reduce the height, it will take worker 2 worker 2, right? Worker 2 will multiply by 1, then worker 2 multiplied by 2, and the worker 2 will multiply by 3. It will be somewhere like we have the worker 3 as in 1, so it will be 1 multiplied by 1 plus 2 multiplied by 1 plus 3 multiplied by 1. It will be 6 seconds. It will take 6 seconds, and we are supposed to fetch the minimum value, right? Simultaneously, the minimum number of the seconds seconds to make the mountain height 0. So to reduce the mountain by 1, it take worker time. Once again, since they work simultaneously, so time needed to reduce as max of why?
Vinod,
This is a worker 2 reduces the height by 1, and we have to reduce the max height by 4, right? So it reduces by 1. Worker 1 reduces the height by 1. Worker 2 reduces height 1. And worker 3 reduces height 1. That will get only 1, right? And for that, now max of 20, max of 2 comma 3 comma 1 will be 3, and this will be the answer. Okay, so somewhere I think I've been able to understand the question. However, if we'll try to get the answer by the same method for the next example, so then we can move for the operation part, coding part, right? So we are given mountain height as in 10, whereas the worker time array is given as in 3 comma 2 comma 2 comma 4, and we are supposed to find the minimum time required to reduce the mountain height to 0, right? Which is 10, right? And all the workers are working together simultaneously. That means the operation will be performed all each time. So worker 1 will reduce, if we'll take worker 1 will reduce by 1, right? And this will be a 3, it will turn as in 3. Now we'll take worker 2 by 2, right? So we'll take 2 plus 2 multiplied by 2 is equals to 6 seconds. So it will take one, it reduces by one, and two, it totally reduces by three. And now we still left with the seven, height of the seven, right? And if we can say the three, worker three will reduces by two, it will again be the second 6 seconds, right? And worker four, so till now we have five, and we cannot afford to go till the five for the worker four. So we are supposed to write three. If we can convert it into three, one, three, three, we have seven, then one. It will be eight max, right? Okay. So one, four, four, one. We can reduce it by this, right? So worker one will reduce the time by 3 seconds. But if we'll go with the two, right? It will go four multiplied by two, eight. So 4 plus 8 will be 12. And if we'll go with the four length of this, so we can, it will be done as, it will be somewhere like 4 plus 8, it will be 12. So it will be 2, 2, 2, 3, 3, 4, 2. So it will be somewhere like for the three version, it will, if worker one will go with the two distances to reduce the size of the mountain, it will be 3 plus 6, which is 9. Worker 2 will go, hey, what if we'll try 3 plus 3 plus 2 plus 2, right? So it will go for the 3. We have 2 plus 4 plus 2 multiplied by 3, which is 6. So we have 12. 3 will also have 12, and the fourth one will also have 4 plus 8, which will be 12, right? So 2 and 3. Max we get 12. Yeah. So max of height will good. So it will be 9, 12, 12, and 12, and will our answer will be 12. And it will actually the answer of the question. Okay, then if we'll try same concept with example number 3. Example 3 is given, and we'll try to understand and solve the question as well. Are you serious? So we can do perform the task by numerous steps. So example number 3 is basically we are given a height of the mountain is 15, right? And array is given worker time as in 1, So our output will be height is given 5, worker time is given 1, and only one worker is given also. So for the 15, if we'll go with the worker in for the height of 5, if we can go, how it could be output, how output would be the one? Oh, there is no worker, right? There is no another worker, so we have to worker one will do all the task, and for X height we have to perform its task as in 5. So first it will be 1, then 1 into 2 plus 1 into 3 plus 1 into 4 plus 1 into 5, and this is 10 plus 5. It will be the 15 output, right? Okay. So I got the pattern, but the thing is that we are supposed to perform operation which will be used, and what algorithm will use here, what will be the pattern for this question. Because so easy to do. यार मेरा हेडेक इतना हो रहा है कि मुझे कुछ समझ ही नहीं आ रही क्या करूँ मैं। But since I have to work on Definitely. I have to. So our question was, now we'll try to understand what exactly its solution could be or the pattern that should be we follow. So in terms of solving this question paper, right? So to solve the question paper, the very first thing which is to understand what exactly the question is, and so this question can be solved using binary search along with MinHeap. So first we'll go with the concept of MinHeap, and then we'll go with the binary tree. So first we'll try to understand the concept of MinHeap in terms of this question, MinHeap, and then we'll go with the which is binary search, right? So it says that the intuition behind the algorithm, which is using MinHeap, as to always assign a next part of the mountain to the worker who will finish their current task for, at the fastest, right? And this is done using MinHeap, which is we basically call as in priority queue. Okay. I think first I should take medicine, then I will solve that. So, no, sorry, I can't medicine. Take medicine. So the question says, as we understand understood what exactly the question says, now we'll try to solve the question and the coding part will be here. So we decided to go with MinHeap by using priority queue, and the basic reason for using this algorithm was to always assign the next part to the mountain to the worker who will finish their task fastest and the easiest, as the fastest, right? Alright. Hmm. So the approach will be, the approach will be first will start the current time. The worker, Mhm. So worker is already spent current time finishing earlier tasks. They see we have this mountain and the worker array. Worker of I has a start has worker has already spent current time finishing earlier tasks, right? Finishing earlier tasks as we have the algorithm uh, given as an if a worker of I is willing to finish the task, reduce the mountain size by X. So we have to follow the certain algorithm, which is worker of I multiplied by 1 to worker of I multiplied by X, right? And this is the time they have used so far to get where they are, right? And the second point is of the approach is time per task, which is task completed plus 1. This part calculates how long it will take the worker to finish their next task. Time per task is the constant time this worker takes to complete the task. Now we'll go for the task completed plus 1 represent the next task will completed. Next what task they will complete. Since task completed tell us how many tasks they have already finished. We'll add plus 1 to find out what task they are about to complete, right? Adding these together by adding current time per task multiplied by task completed plus 1 will get the total time the worker will spend once they finish their next task, right? I don't think you were being able to understand this question as well. So yeah, we'll move to another question. I think you been able to understand the question and there was so now we'll try to code this question, this approach that I have dis- told you previously that we will be working on the coding part also. So let's say the code we are the array we are given min the function we are given minimum number of second, and we are given parameters in mountain height and the worker time, which is an integer array in the vector format, right? Now we have to create a priority queue to store current time, worker time, and the task count, right? So we'll create Using worker, we will create a tuple of long, 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 and long, right? We created a priority queue right now, which will be worker, the tuple. And see, this long is for total time, current total time. This long is for worker time, and this is for task count, right? Next, we are supposed to initialize the priority queue, which is worker. Here we initialized tuple, and it's a greater worker. I mean, hey, right? Then we write for. Okay, so if we try to solve the same question using binary search, let's just try to how we can tackle the question using binary search. So binary search for minimum number of seconds when worker can reduce the whole mountain, right? And to find how many times X, right? How many times X a worker with the time T can decrease the mountain within M second. You can use the simple mathematics, which is simply T multiplication 1 plus 2 plus 2x is less than, right? If it is, we can also write it as x multiplied by x plus 1 divided by 2 is less than or equal to m by 2, right? Now we can write it again as an x multiplied by x plus x or less than or equal to m by 3 multiplied by 2. We can do it as x multiplied by x plus 0.25 less than or equal to m divided by 3 multiplied by 2 plus 0.25. Why we added? Because okay, so make me understand this question and be able to understand the solution as well. Let's do what exactly was first. Understand the question, how to think about the solution, not just final answer, right? Okay. So what exactly the problem is that we a mountain with the height of h, several workers who can reduce the mountain height. Each worker works repeatedly, but each next unit takes longer, right? Or the find the minimum seconds to needed at the mountain height. The key rule about worker is if this T means to remove first unit height will take 10 seconds, remove 3 units height will take 2 t seconds, and remove 3 units height will take 3 t seconds. And for example, worker time is 3. First is 3 seconds, then 9 seconds, and total will be the 18 seconds. The important idea of cumulative time. If a worker removes k times, it will require them for t of comes from the sum t is equals to t multiplied by 1 plus 2 plus 3 to k. This triangle formula, right? What the question is really asking is the problem gives the mountain height T1, T2, T3, and the workers simultaneously need to smallest time in such a worker together can remove the at least h units. So, for in and and t seconds, how many units height of the worker will remove? This two. Then combine all the workers. The core algorithm is idea is the minimum time such that something becomes possible is the binary search and time. There's a time search check how much mountain can work and remove each time. I- If enough, try smaller time. If not enough, increase the time. Or we find the minimum valid time. Mental model of the is that mountain has 20 workers with 3 problem after 10 seconds. How much time is done? Maybe 5, not enough. 30, maybe 22. So it's somewhere around 30, and now binary search narrowed it down. So inside, you must recognize while reading the question, immediately notice pattern, triangular rays, minimum seconds, final simplifying understanding, and so main goal, how can I know which DSA to use for this particular problem, right? So whenever the problem asks minimum or maximum problem value, the first big signal is typical DSA will be the follow that binary search or dynamic programming sometimes. So here we'll some solve it by main head. Yeah, to you. Okay. So second clue is that monotonic behavior that will be followed by the question. It is asked that the mountain can become zero in t seconds, and will it be possible in t plus 1 seconds? Yes, because worker will only do more work with more time. So time 5 is not possible if we have time 5 is not possible if we have uh, a length of mountain as a right, and time 2 is not possible. Time 20 is possible. Time 30 is possible. Fast false true. So this monotonic pattern is exactly what when the binary search work. So now we are confident that main DSA will be the binary search. Our next question is actually what do we binary search? What do we binary search? We binary search the time range from left, which is 0 seconds, and right, very large possible time. So if a worker for mid second, can they remove the whole mountain? For each worker, their work time is like T, 2T, 3T, and 40 kind of stuff, which we can say is equals to T multiplied by K plus 1 by 2. It's just a math. It's not just a math. It's just a math, not a separate DSA. From the given time T, we calculate how many units that worker can remove, and then add all the workers' time. If total is greater than mountain height, time works. So the full DSA is structure boundary search on answer mathematical formula for the temporal pattern. No complex structure will be used here, such as graph, trees, heap, DP table. How you should recognize and future minimum maximum first boundary use three condition minimum zero use. Mental shortcut is the find. Okay, so some solve. Yes, you're correct. The confusion is normal because two different DSA approaches and solve the same problem. I think that's why I feel tired and my headache is somewhere. I feel heavy because I am sleepy right now and my mom will kill me if I will go for the sleep, but I have to for the sleep. So I am doing stop this live. Is there any option to cut this live off? And will go to sleep. Because I need to sleep right now. No matter what. So I'll try to go if she will force me to be awake. I will definitely be back. Yeah.